This is the video concerning double and triple bonds. By the end of this video, you should be able to draw Lewis structures for covalent molecules containing double and triple bonds. Also, you should be able to identify shared, unshared, bonded, and unbonded electron pairs. Materials you need: a pencil, a periodic table, and the Lewis structures containing double and triple bonds worksheet, because this will be due the next time you have class. Whenever you do a Lewis structure for a covalent molecule, you have the following three things to do. First, to determine the number of valence electrons, then to figure out the center atom, that's the one with the closest to 4 valence electrons, and add bonds so that you can follow the octet rule for everybody, but also use the correct number of valence electrons. Let's get started. Nitrogen, and keep in mind the reason why it's N2 and not plain old N is because nitrogen is diatomic. Nitrogen, there's 2 nitrogens. Each nitrogen has 5 valence electrons, so we're going to have 10 valence electrons total. Now in this case, you don't have to worry about the center atom. There's only 2. So we're going to go ahead and write down the N with the bond going to the other end. Now remember, whenever you have a bond is going to equal 2 electrons. So we have 10 valence electrons, we've used up 2, we have 8 more to go. This nitrogen has 2 valence electrons, it needs 6 more. 1, 2, 3, 4, 5, 6. So we've used 6, let's subtract that out. This nitrogen has 2 valence electrons, it needs 6 more in order to have an octet, but we only have 2. At this point I have to stop. I've used up all my valence electrons. However, this nitrogen does not have an octet. Whenever you do not have enough electrons to give all of your atoms an octet, you will have to use either double or triple bonds. To do that, we're going to remove 2 of these electrons and make another bond. Remember that every 2 electrons is going to be a bond. So if you have 2 bonds, that's going to be 4 electrons. At this point, this nitrogen here still has an octet. 1, 2, 3, 4 electrons not in a bond, plus the 4 electrons in the bond gives them an octet. But this nitrogen has the 4 electrons in the bonds, plus 2, or only 6. So it still does not have a stable octet. I'm going to remove 2 more electrons. Now it really doesn't matter if I use these 2 or those 2, but I do want to keep the electrons together as a pair because they go together as a pair in an orbital. At this point I'm putting in another bond, and with that third bond, this is going to represent 6 electrons. So at this point I have used up 1, 2, 3, 4 electrons not in a bond, plus 6 in a bond. I've used up my 10 valence electrons. I have used the correct number of valence electrons. Plus, both nitrogens have a stable octet. This nitrogen has the 6 electrons in bonds, plus 2 more, or 8. This nitrogen has these 6 electrons in a bond, plus these 2 is 8. Now yes, these electrons count for this nitrogen's octet and this one, because those electrons are being shared. It's an octet. Now in this case, this here is what is called a triple bond. If we only had 1 bond, that would be a single. And if we had 2, that would be a double. We also have some other things here to identify. First off, shared electron pairs. Electrons in a bond are shared electron pairs. So these represent shared electron pairs. However, over here, unshared electron pairs are electron pairs not in a bond. This is an example of an unshared electron pair. That would be another one. Likewise, you can also call them bonded electron pairs. Shared electron pairs can also be called bonded electron pairs. Likewise, unshared electron pairs can also be called unbonded electron pairs because they're not in a bond. Let's try our second example. The second example is carbon dioxide. As always, we're going to start with a number of valence electrons. So carbon has 4 valence electrons, plus there's 2 oxygens. Each one has 6. So we have 12 plus 4. We have 16 valence electrons. Now we want to find out who the center atom is. Carbon has 4 valence electrons, which is perfect. Oxygen had 6. So we're going to put carbon in the middle. We're going to put the oxygens on the 2 sides. At this point we have 2 bonds. So we've used up 4 of our electrons. We have 12 more to go. This oxygen here has 2 electrons in the pair. It needs 6 more. 1, 2, 3, 4, 5, 6. Let's subtract out those 6 we just used. That gives me 6 more valence electrons. This oxygen has the 2 electrons in the pair, but it needs 6 more to be an octet. So we're going to go ahead and put out those 6 electrons. At this point, we've used up all of our valence electrons, but carbon here in the center does not have a full octet. It has 2 electrons here, plus 2 more here. It has 4 total. It needs more. Whenever you don't have the right number of electrons, and you run out before everybody has an octet, you're going to have to go to double and triple bonds. So that's what we did. We removed those 2 electrons and moved them up here to make a double bond. At this point, this oxygen still has an octet. It has 1, 2 bonds, or 4 electrons, 5, 6, 7, 8. It has an octet. This oxygen still has its octet. The 2 here, 3, 4, 5, 6, 7, 8. But carbon still does not have an octet. It has 1, 2, 3 bonds, or 6 electrons. So we need to do more sharing. I'm going to pull off these 2 electrons and move it over here and make a bond. Now you might be asking, why move these over? Why not move these over and make a triple bond? The reason why is that usually symmetry is more stable in nature than not having a symmetrical molecule. But if you take AP chemistry, you'll be able to calculate to see why one molecule is advantageous over the other. Let's double check to make sure we've used our 16 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's good. This oxygen has 2, 4, 6, 8 electrons. This oxygen has 2, 4, 6, 8 electrons. And the carbon with 1, 2, 3, 4 bonds also has 8. Now from before we were seeing triple bonds. This one here is an example of a double bond. That is also a double bond. Let's identify our shared electron pairs, which can also be called a bonded electron pair. Right here, we have electrons in a bond, which would make it a bonded pair. It's also a shared electron pair because these electrons are being shared between carbon and oxygen. Over here on the end, we have unshared electron pairs on the oxygen. They can also be called unbonded because those electrons are not in a bond.